angle side, which is not something that law of sines applies to. There's not enough information. You following me?
Yep.
There's not information in the right places to use the law of sines. So today's lecture is all about these two patterns of given information, either side angle side, as this one is, or side side side. And because the law of cosines is not really that hard to do, they're going to throw an extra half of things in here that apply to triangles in these patterns that don't have to do with finding missing pieces. It has to do with finding the area of the triangle straight away. So this section is packed with stuff, but none of it's very hard. Okay. So in a situation like this where we can't use the law of sines, the only thing we have for an oblique triangle like that, what are we going to do? Well, we invent a new rule. So yesterday we started out by inventing the law of sines by taking an oblique triangle, something like that, and we labeled some things. This was C. I'm going to put C on here in a special way. You'll see why in just a minute. Little c, put A here and B here. That means this needs to be A and C and B. Got an oblique triangle, and we don't know how to do anything with this except with the law of sines, and most of the time, or sometimes that doesn't work. So I'm going to drop an altitude again. If you drop an altitude and call this H like yesterday, now we've got a couple of right triangles, which we know an awful lot about, that perhaps we can build something with to handle this kind of situation. This one is a little bit more difficult to develop, but I want to see if you can understand, or you can tell me why things should be the way I've written them. If I write a squared equals, oh, I got to put a couple other things on here. If I make this x right there and this c minus x, that makes good sense, doesn't it? Okay. All right. So if I write a squared equals c minus x squared plus h squared, what causes me to be able to believe that's true?
Pythagorean theorem.
Yeah. Look at the diagrams. Pythagorean theorem on the little triangle, right? Okay. So I'm going to write Pyth theorem. That's what allows me to know that this is true. What I'm doing is keeping track of the things that I'm going to develop here so that you understand that it's what we do from one step to the next is reasonably mathematical. Okay, so the next one I'm going to write, and I don't expect you to come up with this, but I expect you to see what happens from step to step. C squared minus 2cx plus x squared plus h squared. How come we can do that? Yeah, we squared a binomial. A lot of people would call that FOIL. You know, that isn't the only place FOIL applies, but we applied it here. Is that okay? I'm just going to write that down that way. So we all know that that can happen. Now, how about this? A squared equals c squared minus 2cx plus b squared. And the way you do this, see what's changed. There's a squared equals c squared minus 2cx plus that turned into that. So now that's where you need to focus your attention. Why can x squared plus h squared be called b squared? Pythagorean theorem and substitution, right? Replacing x squared plus h squared with b squared, because that's what they're equal to. It's Pythagorean theorem and substitution. Okay, this one's a little tougher. See if you can think about this. A squared equals c squared minus 2c times b cosine A plus b squared. You don't believe that's true? You don't?
I do.
Okay. Why?
Because the cosine of angle A is x over b. You multiply the b, you get b cosine A equals x, and then you can substitute that in.
Did you catch that? Here's how you investigate something like that. First of all, you notice that the only thing changed was x. That is the only thing that got replaced with this. And it got replaced with a trig function, which we haven't seen yet. So you might ask yourself, what do I know about that trig function? Go back over here and go to angle A and ask yourself, what is the cosine of A? And see if it involves these things. That's probably just what case you did. Y'all see it? So this we would actually call the definition of cosine, cross multiply, and substitute. The reason why that was so hard to see is because all three of those things had to happen. Mostly in your head, because nobody drew it out. I didn't see anybody picking up their pencil to write anything. So that's the reason why that was so difficult to come up with, because three things happened in that line. We used the definition of cosine, we cross multiplied, and then we substituted what x was after the cross multiplying. Everybody okay there? Okay, how about this one? A squared equals c squared plus b squared minus 2cb cosine A. How come you can do that? First of all, is there anything that changed? What changed? No, there's nothing to distribute because there's no plus or minus signs in there. The only reason we put that in parentheses at all was to try to point out that x got replaced with this. That's the only reason it is. There's no reason to have that mathematically. It was just to point out that that was the replacement in the previous step. There's no reason for those parentheses in this step, except for to point that out. So mathematically, it's not necessary. So it's not a distribution. It's not even a multiplication.
Nothing's different. It's just
Oh, that's. I was thinking that was BC. It's not. That's the C that belongs to the word cosine. Okay, I was going. Got too many C's there. No, we're good. So what'd you say? You just what? You just rearranged them. What allows for that? Why do you? How can you just rearrange terms? It's a really formal name that you learned one time and you've probably forgotten. It is the commutative property of addition. If you're adding a bunch of stuff together, you can put them in any order you want. You can commute them, right? Okay, well, guess what? What we've arrived at is the law of cosines. Now, I need you, like you did with the law of sines, I need you to memorize this according to how things are on the triangle, not by letters. If you memorize it by letters, you're going to have a lot of memorizing to do, and it still won't apply to every triangle. Okay, here's the way I want you to look at it with respect to this triangle. First of all, I don't want you to focus on the H. That was just to help us get to this oblique triangle. Take all of this off here, and I'm going to even take this off and rename it C, because it's all about this oblique triangle. Here's what I want you to notice. A couple of things. I'm going to be pointing to the picture sometimes. I'm also going to make you look at these patterns here. First of all, the law of cosine starts off with a side, and it's squared. Right on the heels of the equal sign are the other two sides squared. In other words, this is like Pythagorean theorem, only it applies to the first part of it, doesn't apply to a right triangle. But it starts off with any one of these three sides. We could put C squared here, and then this would be A squared and B squared. We could put B squared here, and this would be A squared and C squared. In other words, you start off with a side, and the other two sides follow right on the heels, like if this almost as if it was Pythagorean theorem. You with me?
Yeah.
Then, this last term always has a -2. You're just going to memorize that. It's just a -2 right there. But whatever you squared here and here belongs singly here and here multiplied. This term is made up of these individuals all multiplied together with a -2. And then it's always cosine, and it'll always be the cosine of the angle opposite of the one you started with. These two things are like bookends. You start off with a side, you end up with a angle. And everything in between is the other two sides. I don't want you memorizing it with A's, B's, and C's. I want you to memorize it with, start with a side, end with its opposite angle, and the other two sides are in the middle. You have to memorize what goes with it, but I don't want you to memorize it by A, B, and C. So, That thing's really crammed in over there, and I got all that stuff filling around it. I'm going to erase this development, except for this right here, so that I can apply it to that and show you how it's going to work on these. I don't require that you know how to develop this. I just wanted you to see in your own mathematical minds that it works, and that the development of it is good sense. Start out with something very clear like Pythagorean theorem and end up with the law of cosines. Okay, so applying that to this, I'm actually going to call this something else. I'm just going to call it x so that we don't depend on a's, b's, and c's. If I want to find x, that should probably be what you lead with. It starts off with the side. If you're looking for the side length, then start there. So it would be x squared equals the other two sides squared minus 2 times those two sides multiplied cosine of the side opposite that I started with. You see all that plug in? Okay. Then all you got to do is crank out that right side. There's nothing to solve for. What?
Well, I was just saying this is way easier than yesterday.
Oh, okay. Well, it's the first example. Wait till you see the tough parts. Okay. So this is going to be, we calculate that, but don't forget, when you calculated this side, you have x squared, not x. So make sure you're square rooting. What's going to happen is you'll get this side, you'll go, that is way too big. Maybe that will remind you because it's so huge that you need to square root to get these sides, because these are all rather small numbers. This one will be smaller than the 10, I'm pretty sure. I'm not certain of that, but I don't know. But they'll all be about, this isn't going to be in the hundreds. So don't forget to square root. What do you get? To the nearest 10. Make sure you're in degree mode, folks. You have to be in degree mode because angles are in degrees here.
10.1.
Okay, so they were about right. 10.1. This is 10.1 and this is 10. Then this is probably really close to 72 because this is pretty close to being isosceles. You know what I mean?
Yeah.
Okay, and this will be whatever remains. But we could go after those angles. You want to see that next? Because that's where the tough part is. Should we go ahead and finish solving this triangle?
Yeah.
Okay, I'm going to write 10.1 here, but I'm going to try not to use that.
I got 10.7.
Oh, okay. Somebody screwed up. Who else got 10.7? Okay. So we'll make that 10.7. Can somebody give me 4 or 5 more decimals just in case we have to use this? I think we will.
0,
3,
0, 3, 1.
0, 3, 1, one more.
4.
Okay. All right, we'll go with that. And you should write these down. When you're using law of cosines, there's a good chance you're going to have to use these approximated things. So make sure you got plenty of decimal places so that you're not too far off. Okay, I'm going to erase this part. And now we're going to go after, now we need some names. I'm going to call this ABC. No particular reason it's in that order. If I want to go after angle A, now pay attention here because this is where it gets rough, folks. I'm not using much of the board. You got this down or on a picture or something somewhere? So I'm going to erase this so I got this space over here to use so that you can all see. Otherwise, look down around here. Okay, so I want to go after angle A, which means I should start off with what? If I want to find angle A, I should start off with? No, I should start off with 100. Because the side opposite the angle is where the thing begins. Remember? Remember the bookends? If you're looking for angle A, it'll occur at the end of the law of cosines. We need to start with its opposite side. You see what I'm saying? It's a bookend kind of thing. I'm looking for A, I start off with little a. Equals. Now the other two sides come in next. That'll be 64 plus whatever 10.70314 squared is. Are you with me so far? Okay. Minus 2 times 64 times 10.70314.
Isn't it just 8 and 10?
Oh yeah, just 8. Yeah, just 8. You're right. 8. Yep, thank you. 8. Then the cosine of A. Follow all that? Did you follow the pattern of the law of cosines? Because if not, I can show you. You need to show? Okay. I'm looking for A. If that's where I'm focusing my attention, I've got to start off with the opposite side. You okay with that? And the other two sides come next, squared. So I have a squared, little a squared equals one of the other sides squared plus the other side squared minus 2 times those same two sides not squared. Cosine A.
And it doesn't matter which order any of that is in, just as long as the other two sides.
As long as it's the other two sides, yeah. And the squaring, yeah, because we're adding here and we're multiplying here, and both of those can be done in either order. It's just the other two sides. Everybody good? Now notice that I'm after the size of angle A, and it is locked behind several doors. I mean, it's like he's in solitary confinement. He's back there a ways. Now, here's what I want you to notice, and this is the big mistake people make. So if you haven't paid attention to here, pay attention now. The main thing that you have to observe to get this done right is that on this side, this is a term, this is a term, and this is a term. A lot of people want to, this is what they want to do, and I'll tell you, and it's wrong, and you know this, but it may not be so clear to see. They want to take this plus this minus twice this equals cosine A. That's wrong. Can you see that's wrong?
Yeah.
Because this piece right here, that big monster in front there, belongs to this term. It'd be like saying 2 plus 4 minus 3x, and you go 2 plus 4 is 6 and subtract 3 and then multiply by x. You can see that's wrong, right? I mean, correct? Yeah? Okay. So when you go to solve for A, you have to unlock the doors algebraically correctly. So the first thing I'm going to do is take 100 minus 64 minus 10.70314 squared. I'm going to get rid of these two by subtraction. But what that leaves is this entire term over here. And in order to unlock the next door, which is to get this peeled off the cosine, it's by division. You understand? Yes, by division, you're going to get rid of that. So it's going to be 100 minus 64 minus 10.70314 squared divided by negative 8 times 10.70314. And that equals the cosine of A. And then we have to unlock the cosine. You want to put that on your calculator once? You're crazy. Don't do that. Get your numerator. Hit enter. Divide it by, and then parenthesize this, because you'll screw it up if you don't. Parenthesize this whole thing. Divided by, that answer, divided by negative 2 times 8 times 10.70314. Enter. Then inverse cosine answer. Do not try to put this all in at once. You can. Lots of parentheses, hard to keep track. A lot of people aren't very successful with it.
I think I'll just go through steps. What'd you get?
When you're done calculating, check with your neighbors and see if you got the same thing they did. And remember, you should be in degree mode for this exercise. Yeah.
Oh, Casey, what you get? Look up the name.
62.69.
2.69?
62.69. Yeah, that's what I got.
2.69. Oh, 600.
I didn't use.
No, it's 600.
I just did
Ah.
62.7, is that what you're getting? Yeah, 6.9.
I use the exact value.
Okay, I got 6.9 too. I was just rounding. They'll usually have you round. They'll actually have you round sides to the nearest tenth and angles to the nearest degree, but sometimes the nearest tenth. So I'm going to go with the nearest tenth. So angle A is 62.7. Did you get that or not? About? And then finding this last thing right there is pretty easy now. We take 180 minus 72. We get that the other one is 45.3. Solved.
All of that.
I wrote it right. Okay, so that triangle is solved. Did you understand how we got that? Okay, we found a side using this directly where x squared is what we let off with. All we had to do was square root what we had on the right, but then finding an angle takes a lot of work. You have to subtract two terms, then divide by the leading coefficient, or not leading, but dividing by the coefficient on the cosine, and then inverse cosine that quotient. It takes,
Could you use the law of
takes some effort.
cosines to do this as well?
Yeah, that's a good question. Just a minute. After you find an angle, can you jump to the law of cosine, or law of sines? You could, and about 15% of the time, you'll be wrong. And it has to do with the fact that cosine of obtuse angles is negative. That'll screw things up. Anything past 90, the cosine of it's negative. And that'll mess things up for you about 15% of the time in the problems that I've seen. So the rule is, and I know this is going to come as, you can use the law of sines and you'll be right most of the time. If you want to be right all of the time, if you start out with cosine, law of cosines, because of the way things are arranged, you start out with law of cosines, stick with it. Then you'll be correct 100% of the time. Okay? If one of your missing angles is obtuse, the cosine return on that may not be, depending on the situation. So that's, I'm not going to go into those details. Just remember this. If you start out trying to find something with the law of cosines because of the arrangement of the given information, stay with it throughout the problem. Then you won't have an error. If you jump to sines, you're risking getting a wrong answer. Okay. We just solved the triangle, so we got that one out of the way. Let's try and do one with a side-side-side situation, because that's also in here. This was given, the given information was side, angle, side. Okay, so side-side-side means we've got to find two of the angles using this method I'm erasing. And then we can find the third by subtraction, but you're going to have to use that thing twice if you've got a side-side-side situation. I'll leave that up there. So let's take the one that I got. We've got a 9, 7, and a 5 on a triangle. 9, 7, 5. That's all you get. It's a side, 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 given stuff. You're going to need to call the angle something. I'm going to say PQR to you don't get stuck on ABC. And it can be in any order, doesn't matter. But PQR there, I need to find PQ and R because I have the three sides, I need the three angles. Which one do you want to find first?
P.
P. Okay, then what shall I start with?
47.
49.
9.
If I'm looking for angle P, I want to start with the opposite side squared. Are you with me? You okay with this? Okay. Equals 25 plus 81 minus 2 times 5 times 9 cosine of P. If you memorize your law of cosines well enough to see that this is correct, then the next thing I write is 49 minus 25 minus 81 divided by negative 2 times 45 inverse cosine equals P. Did you follow all that algebra? Yes. All right, start calculating. What did we get?
50.7.
Okay. If you're tempted to go to the law of sines next, go right ahead. You may be wrong. I'm going to stick with cosines. Which one do you want to find next?
Let's do R.
R, what shall I start with then? 25 equals 49 plus 81 minus 2 times 7 times 9 cosine of R. You okay with that?
Yeah.
We'll jump to the algebra because you guys are all really sharp. We can get this done really quick.
Yeah, so this would be a pretty quick question. I better count this.
And when you find R, find Q. And don't use the law of cosines to find Q. Anybody willing to share?
33.6.
Sorry?
33.6.
Anyone else? Is that what you're getting? Yeah?
33.
And this is
95.7.
95.7, you said?
Yep.
Okay, so. So you got this?
Yep.
There's only two things that you gotta find, the length of a side, and you start off with that missing side here, right here, or an angle, in which case you start off with that angle's opposite right here, and you use the other two sides as you go along. How many of you have this memorized right now? How many of you believe it will stay in your memory solid by the time you get to Sunday night on the 18th?
No.
It's pretty simple.
You should do some of this. Don't just go home and shut your books for a week or 10 days. Well,
Okay.
8 days, and just try this a week from Sunday. That's just not gonna work for you, I promise. It's just gonna be bad. Okay, now I want to talk to you about the two other things that are in this section. It has to do with finding the area of a triangle. If you are given information in side angle side or side side side, any triangle, it's really cool. It really is really cool. Any triangle, oblique, right, I don't care what it is. If the information you know about the triangle is in one of these two patterns, there is a formula for finding the area of that triangle, the space inside it, directly. I want you to take a look at the first one. I'm going to derive this one. I am not deriving the next one. So this is an oblique triangle. I know it looks like a right triangle, but it's oblique, okay? And we want to find the area of this triangle. We all know that the area is equal to 1/2 the base times the height, where the base and height are perpendicular. So if I want this to be the base, because to most people base means bottom, I'll go ahead and go with that. If this is the base, then this has to be drawn into the triangle perpendicular there, and that has to be called the height. Yeah? And then if that's the case, then it is 1/2 base times height. This base times this height. If I decide that this is the base, then I have to draw a line from here up to that base perpendicular to it. And this can be the base and the height. So it could be oriented differently, but they have to be perpendicular. That's what classifies them as the base and the height. Now, if the given information, before I drew that height, if the given information was in side angle side form, like for example, I'll just call this 38 degrees. And this side over here, I'm going to say was 10. And this side down here is 12. I have a base in this. You see that side angle side 12 is this whole thing, by the way. You see that I've got in the form side angle side given information. And if I drop that altitude, because I only know this formula right here, then I plug things in, I would get 1/2 the base, which is 12, times the height. I don't know what the height is, but I have something that I could write that's equal to the height. Sine 38, good. H over 10. Right? If we use sine, we can use the opposite and the hypotenuse because all of those are parts of that triangle. We can't use the 12 because the 12 bleeds over onto this triangle. We can't use that as part of this triangle. But in this right triangle here, the H and the 10 belong to it, and the thing that links them together is sine. You with me? So I get 10 sine 38 equals H. Okay? So I put that in here for H, 10 sine 38. And I want you to notice what we've got here. Of the two things that were given for sides, they get multiplied right here. The 12 and the 10 get multiplied right here. And then there's a sine of the angle in between them. In the side angle side pattern, the angle that's in between them, there's that angle, that A part, is sitting right there, the sine of that. So in general, we can say this: the area of any triangle of the form side angle side given information will be 1/2 AB sine C. AB being these two sides. Why do we call that C? Because if this is A and B, then this side over here is C, so this is big C. This included angle is the other angle. Does that make any sense to you? Here's your formula for any oblique triangle's area. the area of it, the space inside it for any triangle. 1/2 AB sine C, but only can be used if the given information on the triangles of the form side angle side. So if you really want to do it, if you really want to see this written according to this, if this is side 1, angle side 2, then this is equivalent to 1/2 side 1, side 2, sine A of that angle. It's the included angle. That's how it applies to this side angle side pattern. The two sides multiply right there, half of their product, sine of the angle in between. You okay?
What does this do?
Finds the area of this triangle, the space inside. We're not looking for missing pieces like we were with law of cosines before. That's not, we've switched gears. We're trying to find the area of this triangle. If I know the information in the pattern side angle side, you can use that directly. Instead of having to refer back to here, you can revert back to there, but you can use this directly as well. So if I've got a triangle like this, and I know that this is 4, and this is 10, and this is 58, side angle side, I can say the area of that triangle is going to be 1/2, 40, sine 58. Done. That is the area.
What
You see it? We're okay?
hold on. Oh, there we go.
Okay, the other formula for area, it's area 2. So we're sticking with the theme, area of a triangle, but this time the area is going to be found with the given information in the pattern side. So if I've got an oblique triangle, any old triangle at all, I don't care what it looks like that. I don't think it always look like right triangles, but they aren't. And I know that this is 4, and this is 12, and this is 10, and that's all I know about it. Can I find the area? Yes, you can. And I'm not going to develop this one for you. I'm just going to hand it to you. It's called Heron's formula. Heron, he was a Greek. People who use it have reduced it to Hero's formula. Other people say Hero's formula. This thing can be extremely useful to people that are trying to figure out how many square feet they've got in their land. Even if it's, just let me give you an idea here. Even if the land is shaped like this, it's really strange and bizarre, or maybe even like this. You got your land mass like this, you want to know how many square feet you got in there? You can split this up into triangles like this, and you can take one of the, have you guys ever seen one of those wheels? It's about this big around, it's on a handle, and you roll it as you're walking, and as it goes around, it calculates, usually they're digital these days. Well, if you've got your property and you know your property lines, or you've got a post here, or a flag something or other, and you can draw a line. You can draw a line with your site. You can walk it off and measure these. Then you can figure this out using Hero's formula, because all you have is side lengths. But you got the side of all 3 sides of this triangle, and this triangle. It takes a little while to walk it off, but it's such a strange, weird shape. It would be really hard for you to take this back and use 1/2 base times these. Or, heaven forbid, try to find the area of a pentagon that's not regular. That's impossible. Well, it's not impossible, but there'd have to be something unique, something more to it than just walking off the lengths. But this is cool, because if you're willing to walk a little while and record 1, 2, 3, 4, 5, 6, 7 lengths, take it back and put your drawing down like this, put those lengths on there, you can figure out the area of your space really pretty quick. It's really great for surveyors, because all they've got to do is walk off the length, and then they can find area. And here's how it goes. This is Hero's formula. You're going to need a number called S, and it is not, get this out of your head, it is not the average. It is the sum of the sides divided by, is it the average? I gotta think. Hang on a minute.
Oh.
I don't think it's the average. It is. No, it isn't. Sorry. We would divide by 3 if it were the average. You have to divide that by 2. I remembered that was not an average yet. It's divided by 2. So you add up the sides and divide by 2, and that's S. That's the first thing you got to find, is a value called S. Then the area will be the square root of, and I know this is really bizarre. You wouldn't think this would happen, but it does. S times S minus A times S minus B times S minus C. Those four numbers multiplied together, square root them, that'll be the area of the triangle.
So x equals all that divided by 2, and times that all that divided by 2, times all that divided by 2 minus a minus b.
Might be, well, yeah. So you're gonna need the s itself, and then the difference of the s and the three sides. So there's four numbers under here. I know it doesn't seem like that should make any sense. But the proof of it takes up 2/3 of the page on page 2/3 of the page on page 490. You want to see the proof? Go ahead. If you don't want to follow all the details, notice that the bottom thing that they arrived at is what I just wrote. This together is called Hero's formula. And it is strictly for side, side, side given patterns for finding area. So, to find the area of this particular triangle, S would be what? Is it?
Oh, it's 4 plus 10 plus 12.
And what is that?
26.
26 over 2 is 13. You're right. Okay, that's our S value. So that means that the area will be the square root of, and if the numbers are small, you can do the arithmetic in your head. It's going to be what?
Can you do any order?
Yeah, because multiplication is commutative.
9, 3, 1.
Well, let's see. 13 minus 4 is 9. Yes. 13 minus 12 is 1. 13 minus 10 is 3. So you got to take 13 minus each of those. I also have to use the 13. So I've got 27 times 13, whatever the square root of that is. 7 what?
7, 3, 4.
Okay, I'll stick with that. To the nearest tenth is okay. And this will be in units squared, whatever you measure that off in, meters or feet or whatever. I mean units, yeah, units squared. Hero's formula is pretty cool. Here's the part that's not cool. And I've often been called not cool, and I'm okay with it. You have to have this and that other one memorized. So you got side, side, side. This is Hero's formula. For the side angle side, it is, if you'll remember, area is equal to 1/2 AB sine C. In other words, the two sides multiplied, half of that, times the sine of the angle in between. Okay? Based on those two patterns. So these are the only area ones that we have that are different from 1/2 based on side. But the reason why they were saved for this section is because this section was all about patterns, side, 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 and side angle side. We don't have any area formulas for the other two. Just these two.
Say we're done. We need them. Are we done?
My question is, do you need any more examples? Let me just summarize what you're going to be doing today. You're going to be finding missing sides and angles using the law of cosines. And you're going to be finding areas based on the pattern of the given information. You've got to have both of these things memorized before test time. So 2 area formulas given in these patterns, and the law of cosines for things given in these patterns for finding angles and side lines. I have a lot of other examples, but if you want to get started on it, we can do that. If you feel like you can handle the tools. Okay? You all right with that? All right. You have the assignment. Also, over the week or over this next week, if you want to get started on the review, that'll be fine. I will not officially assign it until Monday, but I hope to test you on Wednesday, coming after the back on this chapter. So don't lose sight of things. My recommendation, and nobody ever follows it, but my recommendation would be to do half of this assignment before the weekend, this weekend, half on Monday or Tuesday, and then spend the rest of the time doing 2 or 3 problems a day until we get back on the review. That would be too bad. Anyway, good luck. See you. Bye.